Hello. As you can see, I forgot to put on the sound, or rather the microphone was set to the wrong unit. So I decided just to make it dub over and explain what happens. This exercise is another application of proposition 1, and we just have to use problem 2 and proposition 1. So we start with the congruent number 6 that came from triangle 3, 4, 5. And it actually has the area 6, so it's straightforward. X equals the square of half the longest side. But it's not quite as the solution. Generally, I like to test the result whenever it's possible. And here we can make an explicit computation and see that the sum is actually a perfect square of a rational number and the difference. As well. So the congruent number 5, we found that solving exercise 2, the triangle giving the congruent number 5. You can see I've put it in pencil besides the problem, but as you'll see, I really have forgotten all about it. So the triangle is 9, 40, 41. And by proposition 1, it's the square of half the longest side. And then we come to n. I hesitated there because the area of this triangle is not quite 5. So we compute the area. Which is of course 180. And then we test. No, we do not, because here I realize that we have to use the triangle whose area is 5. And then I I compute x correctly. And the test again. This I compute on my phone. That's just too much to do by hand or in the mind. So all that's left is to see if the numerator is really an absolute square. And unfortunately, it turns out that it is not. So this is an example where the test is performed in a wrong way. So the result was correct, but the test was done wrongly. So that raises the question whether it's worth checking your results. I do think it is, because you get an extremely good knowledge by doing that. Here I realized that it should be 5 times 36, so n was not 36. And then in a while I realized that I have written n equals 5, so maybe I should not use 36. And the point is that it might as well have been some mathematics that I've missed. And that's why it takes so long to realize that it's a very, very simple mistake I've been making. So finally we are getting it right. You may realize immediately this is a square. It's the square just before 2500. The difference between 50 plus 49. So finally, now to see. We did find two triangles whose area was 210 in problem 2. So I just have to find them. After solving problem 2, or recording the solution, I worked somewhat longer on the program and managed to make a list of all congruent numbers up to 100 and find the triangles, producing them for all except 12, I think. So there are the two triangles. And you can see the area of both of them actually is 210. And now, having done the checks on point A and B, I really feel confident that I understand everything. We understand exactly how to apply proposition 1, so that ends it.